Okay, I think we are good to go. People are joining. Good morning, good evening to everyone, depending on wherever you are joining from. Uh, Thank you for taking the time to attend. Before introduce to our today's keynote speaker, I would like to cover about a few introduction about Sangam 20 and a few housekeeping topics. As you can see, Sangam 20's 12th anniversary and 12 days of inspiration. We are bringing the best of Oracle technology to you. It is a three week festival, and we have 100 plus speakers joining across the globe. We worked hard to get a new content and new speakers to Indian Oracle community. We have introduced a new theme, for example, rapid fire sessions, community sessions. So do not miss anything. This is like a magic of Sangam 20, right? So next slide. Today we have number of expert speakers are joining across the globe. Do not miss any session. I'm sure you will regret later if you're not attending. So so please attend all the sessions. This is one of the crucial slides for Sangam 20. Take a screenshot of this slide and post it in Twitter so your connections also can join. Not only that, you will make a new connections during Sangam 20, right? You can just search a Sangam 20 keyword and you can make a new connections. Remember, knowledge is power as long as it is shared. So do not say with you, share with others. A few housekeeping announcements. So we also invite your comments and questions. Please look at Q&A bottom of your screen. Please ask your questions for the speakers at any point of time. Type in Q&A section only. Speaker will answer appropriately. One of the requests is please prepare your question properly before asking. So do not type like a small question. So please prepare your question properly and let us respect everybody's time. And also, please use a chat box for any support. Tweet about this webinar. This is the only way you can connect with other people, other attendees, speakers. Make more virtual connections. Use Sangam 20 and AIOG hashtags. And presentation material, we will upload the presentation material you can access after Sangam 20 conference. And we have actually excited announcements, keynote quiz. We will share the QR code after Swan's presentations. Participate and chance to win a lot of gift vouchers. And provide your feedback at end of the session. So it will your session will be diverted to the Survey Monkey link. So please provide your feedback. And I'm sure you guys are seeing like a lot of we just prepared very quickly about Juan, and you guys can see that he's like no introduction is required. So he's working working on Oracle database since from 1988. Implemented SDA memory management and shared SQL. A creator of SQL Trace 10046 and TK-Prof, and inventor of weight events, weight classes. I think this is very close to our hearts because one, our community really likes the performance tuning, and also he's the creator of maximum availability architecture and father of Exadata. Oh my God! So we can talk for next 30 minutes. So it's really honored to have you, Juan Loaiza, in our. This is actually dream come true for us. uh, we want to see you physically in India, but definitely we can plan for Sangam 21 in Bangalore if things are back to normal. So with that, I'm handing over to Juan. Thank you very much. You can start your screen and present.
Okay, thanks. My screen should be started. Can you see and hear me now?
Yes, I can hear you, and still we are waiting for your screen.
screen should be up. Here, I'll stop and start again. Do you see it now?
Not really. Let me unshare my screen maybe.
That might do it.
Okay. Can you do it right now?
It should be working. Okay, so I'm going to stop it and start it again. How's that? Do you see it now?
Once gallery view.
Someone said, yes, it's coming. And people say they can see me. So you still
Yeah.
can't see me? Other people say they can. Now let me try.
So we can see you, Yuan. We cannot see your screen, so I think you will have to share your
Okay.
screen.
Yes, so I haven't shared my screen yet. I thought you were talking about my screen being okay, sorry. I thought you were talking about you couldn't see my face. Okay, now can you see this the presentation and see me?
Yes, yes.
All right, perfect. Thank you. So Sai, thanks for inviting me to your exciting conference. I've been very impressed in your organization, and I'm very honored to be able to talk at your conference today. So good morning there and good evening to those in the United States. Today, what I want to talk about is what I call the future of data-driven applications. So this is something that we're really working hard on. It's simplifying the way you create, build, and operate the next generation of data-driven applications. So let me see if I can get this to go to the next page. Aha, okay. So a number of sections here. So first of all, there's kind of very simple stuff, which is we all know that creating value for data is increasingly important for competitiveness. And if you really want to be data-driven, you need to adopt data-driven apps and paradigms. So what do I mean by that? Okay, so first of all, being data-driven apps, they have to create value from data. And there's a lot of new technologies to create value from data. And I list a bunch of them here: machine learning, real-time analytics, Internet of Things, social graph analysis, documents, text search, spatial, and blockchain. So these are all technologies that create value from data. Now, all of these add a huge amount of value that didn't exist very long ago. However, they often come with complex new products and databases that implement, and the effect of creating all these new products is it fragments all the data. Now, a second thing is that these data-driven apps aren't built the way we traditionally build applications. They're built using new development paradigms. So what do I mean by that? What's a new development paradigm? Well, it's things like microservices and events, SaaS, distributed data, CI/CD, it's very popular, API-driven development, defense in depth, and low code. So these are kind of the new paradigms that people are using to build these new data-driven apps. Now, the beauty of these new development paradigms is they simplify the application development. The negative, though, is that they complicate the data architecture. So they simplify the application side, but they complicate the data side of the architecture. And they create a lot more management complexity. So these are the benefits and the challenges. And so what we're trying to do is make this simple. And we're going to do this a number of different ways. And I'm going to go through this today. That's what this talk is about. So I'm going to simplify. We're going to talk about simplifying these new development paradigms by pairing them with what I call synergistic data paradigms. Also by providing easy to use declarative implementations of these new data types and uses, and eliminating the fragmentation of the data by using what we call a converged database for all the data types and uses, and eliminating all the management complexity that comes with it with an autonomous database. So that's what I'm going to be talking about today. I'm going to start talking about the development paradigms. So the very first thing is, and I mentioned this briefly a minute ago, that these modern development paradigms, they complicate the data architecture. And what we're working really hard on is to eliminate this complexity by pairing each of these new development paradigms with what I call a synergistic data paradigm. So it's a data paradigm that works seamlessly with it to simplify it. And I'm going to go through a number of these today and talk about each one. So first of all, let me talk about microservice. So microservice is a very hot development technology. And what we've built in Oracle is something called pluggable databases that simplify building an application using microservice architecture. So we make it simple for each microservice to store its data in a logically separate data container that we call a pluggable database. And the pluggable database can be easily combined or separated to simplify deployment. And they can be separated to create isolation and scalability. So it's a very flexible way of creating microservices. So microservice, for example, sits in an app container on Kubernetes. And for each microservice, you use a pluggable database. And this makes the deployment and development of microservices much simpler. So next, database queues, they greatly simplify event-based architecture. So this is another very hot development paradigm. So we want to make it simple to implement event-based applications using things like Kafka. So Oracle implements event streaming to and from Kafka. So for example, with our Golden Gate replication, you can stream database changes out of the database into Kafka. And we now have a new Oracle feature where we can query events from Kafka into the database. And also very related to events in Kafka is queues. So for decades, we've supported database queues inside the database that provide full ACID transaction and powerful SQL queries over events. And now we're adding a Confluent connector. So Confluent is kind of the company that backs Kafka, Confluent connector that streams events between Kafka and database queues. So you can stream events back and forth between a queue in the database and Kafka in the middle tier. So this makes event-driven architectures much simpler. Next example is data as a microservice, which simplifies API-driven development. So this is a very different way of accessing database data. So we make that simple with something we call data as a microservice. And the way this works is that Oracle database will automatically generate a REST API on top of either SQL or a stored procedure. So the benefit of this is the application can access data in the database using a REST procedure call instead of a standard database client. And this simplifies and standardizes API access to data. So developers these days want to use REST. They don't want to use traditional libraries. You can also have Java or PL/SQL stored procedures that extend microservices within database functions. So that avoids having lots of slow network round trips. It's very similar to a very popular paradigm now that uses JavaScript in the browser to avoid network round trips. So that's how we make API-driven data architecture simple. SaaS, let's talk about SaaS architecture. So again, pluggable databases greatly simplify developing a SaaS, software as a service architecture. And the way it does it is by implementing a secure and modular SaaS application. So where you can create a separate logical database or pluggable database for each SaaS tenant. And this makes it much easier to develop a SaaS app because the tenants become transparent to the application. And it's more agile because it allows you to clone a tenant or move a tenant very simpler. And also the database is enforcing the tenant security. So that greatly simplifies the security of building an app. And it enables tenants to use standard tools. So a tenant of a SaaS app can come and use a third-party analytics tool or query tool directly against their data because it's isolated in a pluggable database. And this is being used today for very sophisticated apps. So for example, NetSuite, which is a very popular SaaS app, Fusion applications, Taleo are all using this pluggable database architecture to greatly simplify and make their SaaS architecture much more powerful. Okay, next, we have a product called Apex, which simplifies low-code application creation. So low-code, the Apex low-code, what it does is it automatically creates an app starting with a spreadsheet or table. So it makes it much simpler to create app. And one of the unusual things about Apex is that it has deep integration with the database that completely eliminates the complexity of things like middle tiers, connection management, state management, mapping database types to application types, scaling, HA, all these things. When you use Apex, all these things go away. And in the next week, we'll be making a major announcement around Apex applications. And with Apex, you can create an enterprise app in hours, and then you can easily iterate the app to match the evolving business needs. So again, we're integrating a lot of technology to make these new development paradigms much simpler, in this case, low-code application development. Another area, native sharding. It's going to greatly simplify distributed data architecture. So we make it simple for apps to deliver what we call data sovereignty or to deliver massive scale using native database sharding. And the idea here of sharding is you take what used to be a monolith database and you break it up into a farm of smaller databases. And this has a number of advantages. One advantage is you can place each shard in a country, a different country, to satisfy data sovereignty. So for example, you can put European data in a European database, Indian data in an Indian database, but you can maintain it as a single logical database. Also, when you shard, when you break up a large database into lots of smaller databases, it creates fully isolated, linearly scalable architecture that scales both in terms of data and users. And the nice thing about the Oracle native database sharding is that it routes SQL automatically based on a shard key. It also runs SQL across all the different shards, and you can add and reorganize shards online. So with Oracle, you get all the benefits of a sharded database with all the benefits of a mature SQL database. So sharding makes distributed data architecture dramatically simpler. Okay, next, let me talk about continuous delivery. So this is a very hot topic in the developer community, CI/CD. And this is something that we've been working on for a lot of years at Oracle. So we make it simple to do CI/CD of enhancements. So the idea here is to eliminate the need to batch changes, data changes in applications into downtime windows. You want to do these on a frequent basis. And the way we do this is we support fully online schema and data evolution. So we've introduced a number of features. One of them is called addition-based redefinition that allows the schema of the database to be evolved online. We also have something called online table definition, which allows the actual data of the table to be changed online. And of course, we've introduced native JSON and XML into the database, which are schemaless architectures. So all of these allow online schema and data evolution. And these technologies are in extensive use today for CI/CD for extremely complex applications. For example, they're extensively used by people like Salesforce, eBusiness Suite, Fusion Applications, and even SAP to make their application updates happen completely online. Okay, let's talk about defense in depth. So that's another development paradigm. And Oracle makes it simple to use that because we allow end user data privileges to be declaratively defined and enforced within the Oracle database. So it complements and simplifies application level security. It ensures that data security across apps, and it protects and defends app security bugs. I'm gonna finish early so I can take questions at the end. Okay, so if you have questions, go ahead and put them into your question box, and I'll try to answer as many as I can at the end. Okay, so that was development paradigms. Now I'm going to talk about creating value from data in new ways. So we have development paradigms. How do you create more value? Well, that's things like machine learning, document, spatial. So let's talk about how these work. So let's start with machine learning. Machine learning is a very hot technology that people are using to create a lot of value from data. And this is something that Oracle, we've been working on for many years. And the idea is we built machine learning directly into the database engine. So you can use declarative SQL to run machine learning directly on the business data inside the database. And we've built dozens of machine learning algorithms, including deep learning, into the database. So these algorithms help with things like making real-time recommendations, like what's the next thing you should buy, what you should look at, fraud detection, sentiment analysis, et cetera. And you can augment our built-in SQL machine learning algorithms with Python and R algorithms. Now, machine learning, we've had actually in the database, we've been evolving it for many years, but now we've made it a free option. So it's no longer a priced option in Oracle database, it's free in all database editions. And by using the inbuilt machine learning, you don't have to move the data out to a separate machine learning system. So we have a lot of different algorithms. We have classification algorithms, clustering, regression, attribute importance, association rules, feature extraction, text analysis. We have extremely sophisticated machine learning that's been built into the database. And what you'll see in about a week or two when we announce our next generation Oracle Database 21C is that we built AutoML, automatic machine learning into the Oracle database. So we'll be announcing that's going to make using machine learning dramatically simpler because most of it will be completely automated. Okay, so here's a quick example of machine learning to predict customer behavior. So you can build and train a machine learning model really simply. You just call the create model procedure. You give it the table name, give it a model name, and the mining function you want to use. And then if you want to use the model, in this example, you're trying to predict sales, to predict which married fans are likely to buy a ticket. So you just call a simple procedure, predict probability of buy season tickets with someone that's marital status. So it's a very short and simple example, but it shows you it's really easy to use machine learning inside the Oracle database. Okay, let's talk about real-time analytics. So Oracle has had the ability to do real-time analytics in the Oracle database for many years. We've greatly enhanced that with our in-memory columnar data formats and automatic parallel processing. So with our columnar vector processing, we're able to run analytics inside the database transparently 100 times faster than with traditional algorithms with no application changes needed. And you can run these either in OLTP or data warehouse database. So it's very easy to take advantage of real-time analytics. Graph analytics. So this is another new area that hasn't existed for very long. So the idea of graph analytics is to perform analytics that were not possible before. So if you have, for example, a social graph, you can find influencers, dependencies, you can find communities within your users, you can rank, you can do something called Customer 360. And we've built a whole declarative SQL-like queries that make running graph analytics really simple. So we have over 50 in-memory parallel graph analytic functions directly built into the database. And again, graph analytics used to be a special priced option, but now it's free in all database editions. And there's a lot of different graph analytic algorithms. So you can detect components in communities, ranking, walking, pathfinding, community structures, all sorts of things. And here's a very simple example of what a graph analytic query looks like. So the language that we use is kind of a variant of SQL called PGQL. And what this does is with PGQL, you can specify graph patterns that are matched. And what you're matching is the vertices and edges in a graph. So if, for example, we have a social graph that says Barack Obama is connected to these people who are connected to somebody else who's connected to somebody else. And I'm not going to have time to go into details, but this is kind of what a PGQL query looks like. The parens match an edge and the brackets match a vertex. So you say select anyone that has an edge where the vertex is Barack Obama. So it's going to find people who are connected to Barack Obama. So it's very, very straightforward to do graph queries inside the Oracle database. Okay, document data. So documents are extremely popular, and there's really two very popular document formats, JSON, which becomes super popular, and XML. And one of the nice things about JSON is that it's the same format used by JavaScript inside the application. So by using the exact same format in the application and the database, it makes application development a lot easier. And we've added a number of years ago JSON natively into the Oracle database. And this allows you to freely mix JSON and relational data. You can index JSON elements. You can have ACID transactions and declarative parallel SQL across all the JSON and relational formulas. So it's very easy to use JSON formats and XML formats in the Oracle database. And here's a quick example of how this works. You create a table, and one of the columns can be of type JSON. It's very simple. You create the table. Here's, in this case, it's a menus for a restaurant. You get the restaurant name and the menu items. Now the menus are kind of unstructured across different restaurants. So for example, you can have the name of a menu item be corn and the price be $1.99. And then querying JSON is also very simple. You can use a simple dot notation to access the elements of a JSON document. So in this case, I'm showing you're accessing the name and price elements of this JSON document just by saying m.menuitem.name, and it returns. It looks just like a table. So it makes it really simple, both in the data formats, the indexing, the ACID transactions, and the way you access JSON in the database. Okay, text search. So text search is another super important thing that's become very popular. And again, we have a technology that allows text search to happen directly inside the database without having to move all the data out to a text search engine. So text search, you can do text search using keyword search or context queries, pattern matching. You can do things like search for websites, catalogs, documents, lobs. And it's not just simple searches. You can also perform complex linguistic analysis on documents to classify them. For example, you can classify customer feedback as positive, negative, or neutral using what's called sentiment analysis. And you can also search JSON and XML documents that are in tables to look at their content. So for example, if you want to find all the purchase orders with a comment field like damaged and delivered, so something you're trying to find things that were damaged on delivery, that's in a free text comment field. You can do that with our text search capabilities. And here's an example of how this works. So let's say you have a purchase orders table. You create a search index on that purchase orders, and the PO doc is a column that's a JSON column. So you say, create this search index for JSON, for a JSON column in this purchase order table. And then if you want to search for documents that contain the words delivery or damaged, you do that very simply again. You just select whatever you want from the purchase order table. And you use this special keyword, JSON text contains. You're saying, hey, this is from the PO doc in the comment field, and it has these words in it. So again, very simple to do text search inside text columns, blob columns, or inside JSON columns in the Oracle database. Very simple to use. Okay, let's move on. Let's talk a little bit about spatial data. So spatial data is also very important. There's lots and lots of maps and spatial data that people are using these days. And again, we've built spatial technology directly into Oracle data. It's extremely sophisticated spatial technology. And what it does is it allows you to analyze locations and networks using declarative SQL. So for example, you can compute the distance between places, assets, and people. You can analyze networks like transportation networks, telecom networks, utility networks, also things like sales territories for a sales force. Oracle Spatial is used extensively today by many governments to plan land management, public safety, defense, do things like map out power networks, sewage networks, water networks, and manage all these networks. So we have hundreds of in-database spatial operators in function. And again, spatial used to be an extra cost option in the Oracle database. Now it's free in all Oracle database editions. And we have, I mentioned, dozens and dozens of spatial operators, very, very sophisticated technology that's already in use by thousands of enterprises around the world. And many of the biggest governments in the world use it to do their land and city planning. Okay, so here's a quick example of how you use spatial. So in this example, we're trying to find all the restaurants that are within 5 kilometers of our home. So again, you just do a regular query, but where you would normally have the where clause, you use this special function called spatial within distance between the two locations, the restaurant location and my home location. And you say the distance that I want is 5 kilometers. And then this query will only return the restaurants within 5 kilometers of my house. So very simple to use, You don't have to create a separate spatial database, move all the data, keep it synchronized, keep it secure, all that kind of stuff. All you have to do is run this little query. Okay, blockchain. Blockchain is another hot area. So people are creating entirely new blockchain databases. And we're going to have an announcement around our database 21C blockchain table in the next couple of weeks. But the idea here is we're building blockchain technology directly, natively inside the Oracle database. And it's very simple to use. The idea of this blockchain is to help identify and prevent changes, illicit changes to data, so prevent fraud. And this is, again, a technology that's free and that's going to be released in our upcoming database 21C, which is going to be out very, very shortly. And the idea is it looks like a regular table with rows and columns. When you create it, all you have to say is, I want a blockchain table. And automatically, when you insert rows into the blockchain table, the Oracle database will cryptographically chain the rows together. It'll create a blockchain inside the table. And we allow this blockchain to be verified and signed by independent participants, and it can be distributed out, the chain digest can be distributed out freely. So with blockchain tables, they look like normal tables, so they're very simple to integrate into apps. They look like standard tables. You use standard declarative SQL. You get all the analytics and blockchain, so you don't. It's very, very simple to use. So here's, again, a very simple example. I'm creating a table called trade ledger. It looks like a normal table. The only difference is I put this keyword at the beginning of the create table statement. That's create blockchain table. Now the database is automatically going to cryptographically chain the rows together. I can insert a row just like any other table. But blockchain tables, one of their attributes is you can't delete or modify data. So for example, if I try to delete a row from this blockchain table, it's going to disallow it. And I'm also going to be able to come back later on and validate the blockchain, validate that no one has changed any of the data in the blockchain. Okay, so blockchain, very simple, a native feature of the Oracle database. Makes using this blockchain technology super simple. You can see this. Just add a keyword, use normal SQL. Okay, here's the procedure that lets you validate the contents of the blockchain table. Again, very simple. You say verify the rows in the blockchain. Okay. IoT, Internet of Things. So Internet of Things, another very hot area. So the idea here is Oracle wants to make it simple to stream and analyze IoT data. And Oracle already used for most of the major IoT use cases in the world, things like phone companies, power companies, things like that. So what we've added is a way to use a standard SQL insert that instead of inserting into a table, it quickly deposits its data into a memory buffer. And then there's an automatic background process that will bulk load that data into the database. And the benefit of this, it makes the SQL insert very fast and very simple. And it's ultra fast. You can get 25 million inserts per second on a 2-socket server. So this greatly simplifies how you create IoT data. And then to analyze the data, in the Oracle database, we have something called time series analytics that enables you to instantly analyze this IoT data. So IoT becomes very simple. So again, how do you do this? Super easy. You create the table. And if you want to create this special in-memory buffer, you just add these keywords, mem optimized for write to the table. And then when you want to insert through that, you do a normal insert statement, but you put this special keyword in it called mem optimized for write, and then the database will automatically handle the very fast IoT streaming capabilities. Okay, so that's the two things I talked about so far is development paradigms and these new data paradigms that allow you to get a lot more value for data. A lot of new technologies, very sophisticated technologies that are made very simple in the Oracle database. So now let's talk about how you converge data to improve value. So this is the next step. So first of all, I like to use the analogy of fragmented features versus converged product. And the best example of this is a smartphone. So it used to be that if you made phone calls, you want to do messaging, you did photos, you have music player, these were all completely separate products. And now, if you take pictures, most of the pictures in the world are taken off a smartphone. Most of the music in the world is played off a smartphone. Of course, phone calls, text messages, WhatsApp messages, all that stuff is on smartphones. So it's all been converged into a single product called a smartphone. And similarly, what we've done at Oracle is we've taken all these new technologies, things like machine learning, JSON, blockchain, et cetera. These originally required separate databases and infrastructure. And now we've just made them features of the Oracle Converged database. And one of the things that's clear is that having a feature, a converged feature, is much simpler than having lots of separate products. Also, it's not just simpler, you get cross-data synergy. So for example, on the smartphone, because a smartphone converges internet and video and photos, you've basically created a revolutionary new product called social networking that uses internet plus video plus photos. Similarly, with a converged database, if you converge machine learning documents, social and location data, it enables revolutionary new techniques like personalization by end user and fraud detection. So converging technology not only simplifies it, it actually enables synergistic new benefits. And this is an area where we differ quite a lot from some of the other technology vendors in the market. In particular, people like Amazon and other niche database vendors, they promote using single purpose proprietary databases for each data type and workload. So for example, I have Aurora for row data, DocumentDB for JSON, DynamoDB for key value, TimeStream, Neptune, Quantum Database is their blockchain ledger, Redshift is for analytics, they have Elasticache, and there's many more. So for every workload and every data type, they want you to use a separate database. What we think is much better is to run a single converged open Oracle database for all the different data types and workloads. And the reason we think this is much better is that for developers, it makes it dramatically simpler to just invoke a SQL statement if you want to run a machine learning query or a graph query or an IoT or spatial or blockchain in a single converged database. So I gave a bunch of examples. You want to run machine learning, just run the machine learning operation. You don't have to stand up a separate database, move the data to it for the rest of your life, maintain that database, secure that database, upgrade that database, deal with all these different problems. So, which is what Amazon promotes, which is multiple fragmented database. And then you have distributed execution and data movement across them. So for developers, it's much simpler. It's also much simpler, a converged database, much simpler for operations. So it's dramatically simpler to have one converged database that runs the entire application instead of making each of the many single purpose databases scalable, secure, available, et cetera. Okay. And finally, let me just contrast open choice strategies. So when we look at some of our competitors, such as Amazon, but the same is true of Google and Microsoft, their databases like Redshift, DynamoDB, Aurora, they run only on Amazon. So once you start using that stuff, you're stuck with Amazon. The Oracle database runs everywhere. So it's much more open. Also, Oracle uses open standards, APIs like SQL, Java, REST, and JSON. Amazon starts with an open source product, closes it, and then adds proprietary interfaces. For example, if you use the DynamoDB interface, you can't run that anywhere else in the world. You have to use it on, once you built your application to that, you're stuck on Amazon. If you use Oracle database with standard SQL, you can run anywhere and you can actually move it to a different database. Okay, so that's how you converge data to improve its value. By having all these different data types and workloads in one database, you actually get synergies across them. You get simplicity of development and you get simplicity of operations. Now, let's talk about our last topic, which is administration, transforming from administration to value creation. And this is something we're talking a lot about. So the next big thing in databases is what we call autonomous database. It's just like the next big thing in automobiles is self-driving cars, autonomous vehicles. That's happening, it's coming. The difference is autonomous databases are coming a lot faster than autonomous cars. So traditionally, a mission-critical database is very complex and difficult. But with the Oracle Autonomous Database, which has now been in production for 2 years, We make data management super simple. So you can create a database in 5 minutes. It eliminates all the management and maintenance. This is available in our public cloud or in Cloud at Customer. And one of the great things about it is it frees DBAs and developers to focus on value and innovation instead of maintenance. So there's a lot to do, and we can talk about that. In fact, in one of the questions in our question period, we can talk about what can DBAs do in the world of autonomous database. There's a lot to do. So autonomous database has many benefits. For example, it greatly simplifies performance. So it's now simple to scale and tune. You can have it has a transparent scale-out architecture, transparent SQL parallelization, transparent smart storage from Exadata, and persistent memory, transparent columnar formats for analytics, transparent indexing for OLTP, transparent statistics and optimization. So it makes a lot of the performance tasks much, much simpler. Also, it makes availability tests, fault tolerance, much simpler. So you get a full fault-tolerant ACID-based database. The failures become transparent to the application. This is a technology we've been working on for many years called transparent application continuity. And it makes things like server failures, storage failures, database failures, site failures, user errors, online updates, all these become transparent, primarily because it's using the real application clusters technology, active data guard, transparent application continuity, all behind the scenes. Security is another one. Security is actually a big pain because security requirements are constantly changing, and doing constant updates is very difficult and time consuming. And one of the nice things about autonomous database is that Oracle owns securing the data tier. And we create a very highly secure configuration with all data encrypted. And then we automatically apply all the online security updates. So it, again, gives developers a highly secure database in minutes. Okay, and then things like sizing and scaling get much simpler in a cloud database that is autonomous. We have a serverless architecture that automatically scales to match the changing workload. So we can instantly adjust the CPU and IO. You don't need to predict the sizing and constantly monitor it. You can also just turn the database off when it's not in use, and you only pay for the required CPUs and storage. So it's a very different world. It's a radically different world from what we've traditionally lived in. In addition to that, in terms of what makes development easier, one of the things we've provided for developers is the ability to use an always free cloud tier. So you can go to the Oracle Cloud and get autonomous database for free. You get 2 databases with 20 gig each. You can get compute for free. You can get storage for free, and you can get networking for free. And you can use our Application Express to build low-code applications for free, as well as our SQL Developer Web. So this is going to make prototyping data-driven apps much, much simpler because any developer can get a free account and use all these very advanced technologies. Okay, so these are the key takeaways from this talk. Data-driven apps are the future, and data-driven apps can become very complicated because of the new development paradigms and the new data types and algorithms. So what we're doing is we've created these synergistic data paradigms for each of the modern dev paradigms to make them dramatically simpler. And as far as the new data types and algorithms, we've added those natively into the database. So you can just call them using SQL instead of having to stand up a separate database. So between these two, it makes building data-driven apps an order of magnitude simpler. Then we can use a converged database for all the different kinds of data and workloads. And this has a number of advantages. For one thing, it's much simpler, but also it allows cross-data synergy, and it greatly simplifies development and ops. And finally, we reduce a lot of the administrative drudgery, which is going to enable developers and DBAs to focus a lot more on innovation. So those are the key takeaways from today, from my talk today. So now I'm happy to take your questions. I think we had a question earlier on, but if you have any other questions, happy to answer those. Let me see if I can bring that up. Excuse me.
Juan, I can just read them to you if that's easier.
Okay, sure. Sure, that would be
great. All right. So the first one that we've got is for Oracle sharding. And the question is, data is sharded and accessible locally or region-wise. How about the packages of procedures or functions? Are they multiplexed across all of the shards? And will the application work if the network connectivity between two sites or regions is down?
Yeah, so those are, there's a number of different questions in there, but those are good questions. So the way the shards work is you break up a big database into lots of small databases, and then the SQL gets routed. So in terms of, I think the last question was, suppose we put a database in Europe, another database in Asia, another database in America. You split up the data, so it's local, so you get fast access. The idea is, if let's say you're in Asia and the US database goes down for whatever reason or becomes disconnected, the users in Asia are all primarily accessing the Asian database. So they won't be affected by any kind of glitch or performance issue or anything else by the Europe that happens in the Europe or US database. So yeah, even if the network goes down to those other regions, you'll be able to take advantage of that. And I mentioned this, but data sovereignty is something. Data sovereignty means countries want to hold the data for their citizens inside their country, whether it's financial data, government data. This is going to become a bigger and bigger deal over time. So you see this expanding. There's going to be more and more data regulations. And when those come around, it's going to be very difficult. If you've created a single database, for example, for all your customers, regardless of country, then it's going to become very difficult to rewrite the entire thing to fulfill these data sovereignty regulations. So by using sharding, we can actually do a lot of the work automatically for you. So that's one of the big advantages of sharding. Let me see, what else was there? Package, procedures, functions. Yes, so I think you can replicate. I'm not an expert on this question, but I think you can replicate these packages and procedures within each region. And then the SQL runs independent of region. Okay, so that hopefully answers most of those questions.
Ready for the next one then?
Sure.
I think this one, you're going to have to let some secrets out of the bag to answer this one. But hi, Juan, okay. Thanks for the nice session. For machine learning in the database, programming knowledge is required. How do DBAs explore machine learning, or how can they take advantage of machine learning?
Yeah, so machine learning is kind of scary, and there's a lot of very sophisticated mathematical algorithms that are implemented in machine learning. But one of the nice things is you don't have to understand all that stuff. I don't understand all that stuff. And if I understood it, I don't understand it for long because I kind of, I take the class, I kind of understand, then I can't remember it. But it doesn't matter because you don't really understand how joins work or how, analytic functions work either. The database kind of does that for you. So today in our 19C database, 18C database, we have machine learning algorithms, but you have to know a lot about the algorithms. You have to know which algorithm to use and how to use that algorithm. Now, you don't have to know how it's implemented, but you have to know at least about the algorithm, about the various different algorithms, how to choose them, how to evaluate the data that you want to run machine learning on. And that's something that we've been working a lot on. So we have this capability called AutoML, auto machine learning, that we'll be releasing very soon in our database 21C that automates that process. So the way that works is you give it the data that you want to predict. So for example, let's say I have an online store and I want to say, I want to predict the people that are buying red shoes, or why someone buys red shoes. So I look at my sales and I say, okay, these are the red shoes, and I can let the machine learning algorithm predict based on what data predicts people buying red shoes. So for example, it might look through all the data and discover that, for example, people between 25 and 30, the age of someone is the most likely predictor for buying red shoes, or maybe someone who's male or female, or someone who's tall or short, or maybe someone who lives in a certain city loves red shoes. The machine learning algorithm will actually automatically discover the algorithm and the data that best predicts an outcome, like buying red shoes, or getting some disease, or using some financial product. So it used to be super difficult to do machine learning, but it's become dramatically simpler, and it's going to become even simpler in 21C. Okay, well, how about another question?
Okay, so to kind of hit on what you spoke at the end of the session, is an autonomous database a converged database?
Yeah, so let me just say, converged database is a description. So converged database is what I call, it's a database that has all the different data types and workloads and development paradigms supported inside of it. So the Oracle database is a converged database because we've been working for decades to build all these different data types, things like spatial, graph, blockchain, JSON, XML, events, all these different things inside of it. So that means it's a converged, just like a smartphone is converged because it has all these different capabilities inside of it. So the Oracle database that you use today is a converged database. It gets more converged all the time. An autonomous database is really just an automated version. It's a self-driving version of the Oracle database. So yes, the autonomous database is a converged database.
All right. One that keeps coming up, and I think it's time to answer, is what will be the DBA role in an autonomous database world?
Okay, that's a good question. So there's a lot of different roles. So traditionally, DBAs have had to do a lot of maintenance work like patching, tuning. A lot of that's going to be automated over time. In autonomous database, it becomes kind of Oracle's responsibility to do that. But that was never really very interesting to begin with. I sometimes, compare it to something like a dishwasher or a laundry machine, a clothes washer. It was never really very interesting to wash your own laundry. So it's better to let that maintenance work happen automatically. So the kinds of things that a data professional is going to do are things that are not maintenance, that require knowledge of the business and of the applications and of the data. So things that aren't the same for everybody, like applying a patch should be pretty much the same for everybody. So things like ensuring end-to-end security, looking at how end user response times are working, looking at how applications are using the database, looking at the data model that's implemented inside the database. I also talked about a lot of these new technologies. So one of the things that DBA can do is learn about spatial, learn about graph, learn about machine learning. None of this stuff is really super complicated, which doesn't mean it's trivial, but it's not super complicated. So learn about the new technologies. And once you've learned how to use spatial technology, how to use graph technology, then you can help your company deploy these technologies to make the applications that the users and the company use much better. So move upstream, learn about these new technologies, learn about these new development paradigms. How do you help someone build an event-based application using database queues? How do you help someone build a microservice application using pluggable database? How do you help someone build a CI/CD application using the online operations inside the database? So that's the things that you'll be working on a lot more. And those, frankly, are a lot more interesting anyways. Okay, other questions?
So one of them goes back to your example of how to develop SaaS apps where, using the Converged database and multi-tenant. And the question was about, do you believe you could extend that to any DevOps for better performance without virtualization, better agility and security? I believe it's multi-tenant is what that's referring to.
I completely understand the question, but yeah, so multi-tenant technology basically has multiple use cases. One use case I mentioned was, hey, you have a separate logical database for a microservice. Another use case is for SaaS, we're using the same application across many customers. So for example, Salesforce.com is a SaaS application. Oracle Fusion Apps is a SaaS application. NetSuite.com is a SaaS application. So what they do is they have the exact same application, let's say a finance application, but it applies to different customers. So we use that technology to the pluggable database technology to isolate each of the different customers. In another case, it's just for consolidating database. So I have 100 databases in my company, 1,000 databases. I want to run 1,000 physical databases. I want to run 1,000 logical databases, and maybe on 10 physical databases to reduce the administrative need. So yeah, DevOps is another thing. so for development, pluggable databases make it more agile by making it easy to do things like take snapshots of databases and be able to give a pluggable database to a developer. So they can essentially have their own database. Developers don't really like to share with other people. So they can each have their own database, but it's a logical database, not a physical database. So you don't have all the administrative hassles of having a physical database. Okay, next question. There was a question about MLE that was just on there. So MLE is a multilingual engine. So that's something that we have for Java, and we're using it for other things. So again, in the very short term, we're gonna release our database 21C, and one of the big new features of database 21C is that we're incorporating the initial incorporation of the multilingual engine natively inside the Oracle database, so that we can implement new languages inside Oracle. So today we support essentially 3 languages inside the Oracle databases. One is, of course, SQL. SQL is a language. Second one was Java, so you can run Java, and of course, PL/SQL. And with our multilingual engine, we'll be able to easily support other languages. So the first language, new language that we're going to support in the Oracle database is JavaScript. JavaScript has become the #1 most popular language with developers. So we're going to be supporting, with our multilingual engine, the JavaScript inside the database. So you'll be hearing more about that in a couple of weeks.
There's a question about since you're letting the cat out of the bag on some of these or giving people previews, there's a question about when do we expect inter-region data guard for autonomous database?
It's a good question. I think it's almost there. It's very close. It's very close. So you won't have to wait very long for that.
Yeah, my answer was soon. Another shout out to you. Thanks, Juan, for an awesome session. In the autonomous database, we only limit tools to support performance tuning. We only have limited tools for support for SQL tuning. For example, SQL-T is not supported. This is a helpful tool for solving customer escalations. Are things going to pan out for us to be able to use this in the future?
Yeah, so autonomous database has certain restrictions. So one of the restrictions is it has only a SQL interface. So the idea of autonomous database is it's like a car. When you have a self-driving car, you don't open the hood and start messing with things under the hood. It's self-driving. So autonomous database only has a SQL interface. So traditionally, we've built some particularly diagnostic tools that dump data outside the database. So we dump things to trace files, like what SQL-T uses. And so those are files outside of the database which can't be accessed using a SQL interface. So what we're doing there is we're going to make that information available from within a view inside the Oracle database. And we're going to let you extract that and put that on a local file system, like on your laptop or something. So yeah, so right now there's a restriction. You cannot directly access trace files. Trace files are kind of an internal part of the Oracle engine. It's not, it really shouldn't have ever been exported that way, but we did it years ago. And I'm partially guilty for that myself. But yes, you'll be able to redo that again. We're going to make that available basically through SQL views.
All right. I think we can squeeze in one more before the session ends. Hi, Juan, your session has been awesome. Do you plan to support Python inside the Oracle database?
Yeah, so the idea of this multilingual engine, and you can actually read up on that, it's something that Oracle's been working on for a lot of years, is it lets us rapidly implement new languages. So what we're doing in Database 21C is we're adding the multilingual engine, so the first version of multilingual engine. And in our release following that, we're going to be enhancing that. And that's going to enable us to add new languages because surprisingly, there's a lot of new language technology that's appearing. So if you go back 10 years, it kind of seemed like the world was converging around kind of Java as the kind of the common language. Now the world is splintered into many, many languages. So there's Python and JavaScript and C# and Objective-C and this and that, the other thing. And there's new languages all the time. So yeah, by incorporating this multilingual language in the Oracle database, we're going to be able to add new languages much more easily in the future. And I think Python, if it remains popular, which it looks like it will, then we'll very much look at adding Python to the Oracle database as well.
All right.
Okay, I think I don't
Okay.
know if Sai is still on, but we're probably out of time at this point.
Yeah, thank you. Thank you very much for your time and supporting Indian Oracle community. And this is the first time. We are so excited, Juan and Maria. You have covered plenty of information to digest. I'm sure we have actually broadcasted all the keynotes in our channels, so people come back with a lot of questions, I'm sure. And also, we hope to see you in Sangam 20 in Bangalore face to face. And thank you so much, Maria, for coordinating and helping. You are totally autonomous, answering questions like anything. Now, time for a quiz time. Um, so here is go, right? So scan the QR code or use the link in the presentation and participate, right? I'll keep this one for 1 minute. We will announce all the winners in our website. Watch the space in our website. It's very important. You basically answer. We want to test your knowledge. And if you're done, then I'm just going to the next slide. Now, this nicely land into the next session, SQL tuning tips you can't do without from Maria Colgan. Let us take a quick break. Join 5 minutes before the session. The actual session starts at 11:30 a.m. India time, and it is too late for Maria, by the way. So let us join on time, learn new stuff. With that, thank you very much, Juan, for supporting us, and we'll see you soon again. Thank you very much.
Okay, thank you, Sai, and I want to thank you and other organizers of Sangam for putting on a fantastic conference.
Thank you very much.